Hi guys, this is O-level chemistry, paper 12, June 2020, question 11. How many shared electrons are in one carbon dioxide molecule? Shared electrons. So the structure of carbon dioxide has a carbon in the center with an oxygen on both ends and a double bond between the carbon and the oxygen atoms. Carbon belonging to group 4 has a total of 4 electrons, all of which have been shared with two different oxygen atoms. Oxygen being in group 6 has 2 electrons shared in the double bond between carbon and oxygen, and it has 4 electrons remaining on the oxygen atom itself. So this is the electron distribution in the outermost shell of carbon and oxygen when they form carbon dioxide. Now the question has asked us how many shared electrons are in one carbon dioxide molecule. So we have got 4 shared electrons on the double bond on the left and 4 shared electrons on the double bond on the right. So in total we have got 8 shared electrons. So this makes option C the correct option for this question. Question 12. Element X has a lattice of positive ions and a sea of electrons. So element X is a metal. Which property will X have? It conducts electricity by movement of ions and electrons. No, only electrons move. Ions do not move in metal. So ions will make this statement incorrect. It has a high melting point. All metals have a high melting point. It is decomposed by an electric current. No, it is not decomposed by an electric current. Electrolysis is not taking place here. Neither is any decomposition. So this is wrong. It is not malleable. It's a metal. Metals are malleable. So this makes option B the correct option for this question. Question 13. Which row shows the correct state symbols for the reaction between calcium carbonate and dilute hydrochloric acid? The conditions are room temperature and pressure. So, calcium carbonate is a solid that reacts with 2 moles of HCl, which is aqueous, producing calcium chloride, which is a soluble salt, so it is aqueous, and water being a liquid, and we have CO2 produced, which is a gas. So these are the states of all the components of the given equation. So let's see which one is correct. All 4 options are giving calcium carbonate as a solid. For HCl, we've got 2 options giving us aqueous and 2 giving us liquid. So options B and C eliminated. We are left with A and D. Next, calcium chloride as aqueous. Both options have this as aqueous. Next, water is aqueous in A and liquid in D. Now the issue is water is the solvent which results in any other substance becoming aqueous. So you dissolve something in water to make it aqueous. However, when you say aqueous water, what does that mean? How much water do you dissolve in water to form a solution of water? Doesn't make sense. So water cannot be aqueous. And the last one, carbon dioxide being a gas, makes option D the correct option for this question. Question 14. The expression shown for the value of AR for fluorine is incomplete. How should the gaps in the expression be correctly completed? Okay, so AR is given as average mass of one dash of fluorine. This would be atom because it is the atomic mass, and dash of the mass of one atom of carbon 12. So it is 1/12 the mass of one atom of carbon 12. So options A and B have atom present, so C and D have been eliminated. A has 1/6 the mass, B has 1/12 the mass. The correct answer is 1/12, making option B the correct option for this question. Question 15. A mixture of 5 centimeter cube of CH4 and 100 cm cube of air are exploded. Okay. Assume air is 80% nitrogen by volume and 20% oxygen by volume. The resulting mixture is cooled. All volumes are measured at room temperature and pressure. What is the composition of the resulting gas? Okay, so now if we have 100 cm cube of air and out of which 20 cm cube is oxygen. So according to the molar ratio 1 is to 2, 5 cm cube of methane would require a 10 cm cube of oxygen, which means 10 cm cube of oxygen is still in excess, right? And at room temperature, this will be gas. Now, CO2 will also be a gas at room temperature, and according to the molar ratio 1 is to 1, CO2 will be 5 cm cube because we have 5 cm cube of methane. So 5 cm cube of methane would produce 5 cm cube of carbon dioxide and it would produce 10 cm cube of water. But the issue is at room temperature, the liquid state of water exists, not the steam as given in the table. So steam will not be present. So this should be X. So we can actually eliminate options A and C because they have steam present. So now we look at B and D only. So 5 cm cube of CO2 is present in both. 10 cm cube of O2 is present in B, not in D. So B is the only correct option going forward. 80 cm cube of nitrogen is there as the question said 80% is nitrogen by volume. So 80%, 80 cm cube of nitrogen and none of steam would be present in the room temperature mixture of gases. So this makes option B the correct option for this question. Question 16. Which arrangement is used to electroplate copper onto a steel key? Okay, if we have to electroplate copper, our electrolyte must contain copper ions. So A and B has copper ions present, C and D have been eliminated. Now anode, anode is a positive electrode. This is where the copper plate would dissolve and ions would go into solution. So we need a copper plate here. So A says piece of pure copper, B says steel key. So B has been eliminated. And cathode would obviously be the steel key because the copper would deposit on it. So steel key. This makes option A the correct option for this question. Question 17. The chloride of metal X is dissolved in water. A concentrated solution of this chloride is electrolyzed using inert electrodes. Okay. And we have concentrated aqueous solution of chloride of metal X. Okay. X is above sodium in the reactivity series, so it is highly reactive. In addition to chlorine, which gas is liberated and at which electrode? So chlorine would be released at the anode because chloride ions will release electrons and form chlorine. So the electrode would be cathode. So options B and D have cathode present, A and C have been eliminated. And since this metal is more reactive than sodium, then hydrogen gas will be produced at the cathode. So B has hydrogen present, D has oxygen present, making B the correct option for this question. Question 18. Which change in conditions for the reaction between zinc and dilute sulfuric acid increases the rate of reaction by lowering the activation energy? Okay, since the question has mentioned lowering the activation energy, the only way in which activation energy can be lowered is by introduction of a catalyst. No changes in temperature, pressure, or concentration is going to achieve a decrease in the activation energy. It will only be by the use of a catalyst. So option A is adding a catalyst. Yes. B is increasing the concentration of the acid. No. This will increase the rate of reaction, but it will not lower the activation energy requirement. C, increasing the surface area of zinc. Again, rate of reaction increases, not the decrease in activation energy. And D, increasing the temperature. Now, this will depend on, okay, increasing temperature also increase the rate of reaction. I was about to talk about reversible reaction, but that is not the situation here. So increasing in temperature will increase the rate of reaction. Yes, but it will have no effect on the value of the activation energy. So this makes option A the correct option for this question. Question 19. Many reactions can be classified as redox reactions. Which equations show redox reactions? Okay, equation 1. Magnesium has a charge of 0 and magnesium chloride has Mg2 positive ion. So magnesium has been oxidized, and in HCl, H positive ion has a charge of +1. It has been reduced to hydrogen gas, which is 0. So this is a redox reaction. In the second case, Fe has a charge of +2 in the reactant side and Fe has a charge of +3 in the product side. Chlorine has a charge of 0 on the reactant side and it has a charge of -1 on the product side. So iron has been oxidized, chlorine has been reduced. So this is a redox reaction. 3. NaBr. Sodium has a charge of 0, bromine has a charge of 0 on the reactant side. On the product side, sodium has a charge of +1, bromide ion has a charge of -1, making this a redox reaction as well. So all three of them are redox reactions, making option A the correct option for this question. Question 20. Which row correctly shows whether hydrogen ion concentration and the pH of ethanoic acid are higher or lower than those of hydrochloric acid of the same concentration? Now, hydrochloric acid is a strong acid and ethanoic acid is a weak acid. A strong acid has a lower pH, a weak acid has a higher pH. And a lower pH would mean greater H positive ion concentration, and a higher pH would mean a lower H positive ion concentration. So our answer would be a lower pH and higher, so higher and lower. So option A has higher and higher, wrong. Option B has higher and lower, correct. Concentration of no ethanoic acid, it should be lower and higher. I'm talking about HCl. We are supposed to answer with respect to ethanoic acid. So higher and lower would be for HCl, not for ethanoic acid. For ethanoic acid it would be lower and higher. So let's correct A as well. A higher is for hydrogen ion concentration, wrong, and higher pH is correct. And C is lower H positive ion concentration, as seen here. H positive ion concentration is lower, so correct, and higher pH. This is also correct, so C is correct. And then D, lower and lower, so the lower pH is wrong. So this makes C the correct answer for this question.